already, please make sure that you put your name on the front of your packet. If you haven't already, please make sure that you put your name on the front of your packet. Today's date is the 24th. The assignments that are due this week, we have a warm-up. We have our homework that is also due. We have a short quiz on midpoint Friday, midpoint and endpoint. And then we have a short one on Pythagorean theorem and distance. Please make sure that you go over your notes. We're doing distance today. We've already done midpoint, endpoint, and Pythagorean theorem, but we're doing distance today, okay? And we have a laws of exponent sheet that is due this week as well. Yes, babe.
What's the second quiz say?
Pythagorean theorem, distance. Tutoring for this week, for those of you that need some extra help, it's Wednesday at 3 p.m. It's virtual. It's always virtual. Today, we're going to do our warm-up. I'm going to, we're going to put notes on distance in our notebook. The warm-up will review Pythagorean theorem and midpoint. Then we're going to practice. We're going to do some problems on distance and finding the perimeter, volume, area, distance. You should know how to find the perimeter, but I'll put that on here anyway. An area. And if you forgot those formulas, then I'll give you the formulas again. Okay? This is what our practice is on. Okay? Homework, of course, is the Monday portion that's in the packet. And you can go ahead and fill that out if you want to go ahead and do that. It's a review of midpoint, distance, Pythagorean theorem. Wednesday, we start a new iReady project. This iReady project is due February the 18th, so you'll know. It's 3 lessons, the same as always. 2 of the lessons is teacher assigned, and the other one is your own track. Friday, you don't have homework unless you didn't do the work from the week, which means you need to do makeup work. So if you didn't finish the quiz or you didn't finish the assignments for this week, don't go back and do quarter 2. Quarter 2 is over. Okay? If you have some last minute concerns, today is the last day that I'm taking last minute concerns about quarter 2 work, because grades for me are due Tuesday, Wednesday. So I have to have time to grade. Please makeup work. If you turn it in on time, it's already graded. If you're turning it in late, that's what I'm doing now, is late work. Okay? So this is your last day. If you have any concerns, you need to make sure that you see me today. Tomorrow will be too late, okay? Any questions, comments, or concerns? If you're not signed up for Remind, please sign up for Remind if you haven't done so. So if you get home and you have questions, you can text me, okay, or email. All right. Let's look at the warm-up. Okay, before I move to the warm up, let me pause real quickly so I can show you, make sure you understand where everything is on Canvas, okay? Okay, so with our warm up, we're gonna go over it. It says the bottom of the ladder must be placed 3 feet away from the wall. So you have to visualize this. So the best way to visualize it is to kind of draw it. This is the wall, and the ladder is 3 feet away from the wall. The ladder leans up against the wall. This is the ladder, and it's 3 feet away. So this down here is 3 feet. Okay, that's your visual. Okay, the ladder is 12 feet long. This is the ladder, so this is 12 feet. And what they want to know is how far above the ground does the ladder touch? They want to know this distance here. Okay. All right. This is a right angle because buildings are perpendicular to the ground. That means we can infer, or it's implied, it's inferred that this is a 90-degree angle because buildings are straight up from the ground. It's a 90-degree angle here. So since this is a right angle, you can use Pythagorean theorem to find this distance here, or this length. So we're going to use a squared plus b squared equals c squared. We're going to label our legs. Remember, our legs are the sides that form the right angle. So this could be labeled as A or B. This could be labeled as A or B. But the slanted side, the hypotenuse, is C. That's the longest side out of the three sides. So now we're going to substitute the information that we have so that we can find find the missing length. Okay. A we don't know, so we just keep it as A squared. B is 3, so this is 3 squared. And C is 12, so that's 12 squared. So now we're going to simplify and then isolate. You got a question? I'm sorry. Are you okay?
Yeah, I'm just confused about something.
Well, go ahead and say, so we can
Why
clear it up.
would you multiply by 2 if you're just going to divide by 2? A plus B equals...
We're not doing. You have to simplify these first.
The theorem. Why would you...
Did you remember? Did you take notes when we did this theorem?
Yes.
Can you pull that out and look at the theorem first and what the theorem states to make sure you understand the theorem? Okay. Make sure you understand this theorem first. So go back and look at the theorem because these are two squares that are being added together to give you the third square. When you add these two squares together, that gives you the third square, but it only works for a right triangle. That's why you got to go back and look at that. So go back and look at those notes because that will answer your question. Okay? All right, and if it still doesn't, then ask it again, okay? All right, let's look at this. So now we want to solve for A, get A by itself by simplifying these. So we got A squared. What's 3 squared? 9. What's 12 squared?
100.
Very good. So now how do we get A squared by itself? Subtract the 9. So this gives us A squared. This is gone, right? What's 144 minus 9?
133.
135. Okay. So now what are we going to do to get A by itself? How do we get rid of the square? What's the opposite of squaring a number? It's square root. So now the square root of A squared is A. How do I know that? Because A times A, or A times itself, gives me A squared. So now I'm going to put, you probably have to round, so I'm going to put about. Squiggly lines is about. So let's type in the square root of, yikes, the square root of 135. And what is that about?
11.6.
11.6, okay? You see that? So we're going to put about 11.6 because we're rounding it to the nearest tenth place. And don't forget to go back and look at those notes to see the picture, especially to see if it helps you understand this. And if it doesn't, just ask me again. Yes, baby. It's in, you need to go back and watch the video. All the videos have the notes in them. Okay. All right, let's do midpoint. Sammy, sit up. poor fella. Yes. Yes. All right, so we're going to find the midpoint. So in order to find the midpoint, we use the formula for midpoint. What is the formula for midpoint? Anybody remember? What is the formula for midpoint? Say again. Say, baby.
Isn't it like y1 times y2 divided by 2 or something like that?
Close.
y1 minus y2 divided
We
by
don't,
2.
but we don't do y first. With midpoint, you got to do your x coordinate. Yeah, you do your x first and then your y. So to find your x coordinate, what do? X1
Plus x2 divided by 2,
mm-hmm.
comma, y1 plus y2 divided by 2.
Yes. Okay. So that's how you find your coordinates. Okay. Yes, baby. You don't have to even. Okay. All right. So let's do our ordered pairs here. So what are our ordered pairs? What's the ordered pair for this endpoint right here? This is negative 1, 2, 3, 4, 5, comma, positive what? 5. And this endpoint here is positive, positive 1 and negative 2. Okay? This is here, this is the first point, x1, y1. Second point, x2, y2. If that's hard to see, you can write it here. Negative 5, 5, x1, y1. 1, negative 2, x2, y2. Yes.
Oh, can I go? So I forgot to go to the beginning.
Yeah, you have to remember yourselves, okay? You just know who's next and stuff. All right. So now we're going to add the x's together. What are the x's here that we're adding together?
-5 plus 1.
Negative 5 plus 1 and divide that by 2. What are the y's that we're adding together?
5 plus
5.
5. Mm-hmm. Very good. So here, when I add these together, what do I get?
-4.
I get negative 4. What's negative 4 divided by 2?
-2.
Negative 2. Okay. That's my x coordinate for my midpoint. Okay. So when I add this together, what do I get?
3.
I get 3 divided by 2, and that gives me 1.5. That's my y coordinate. So this is going to be my point that's in the middle. Okay. Negative 2, go over to negative 2, and up 1.5 is right here. This is my midpoint. Any questions about that? And I can pause for the calls. Your Monday homework needs to be done on a separate sheet of paper because it's nowhere near enough space. It's nowhere near enough space to do that, okay? I'm going to go over. This is Monday homework. We're doing the first one. Please do this on a separate sheet because you don't have enough space to do it on here anyway. So your endpoint, they give you an endpoint is 1, 1. And the midpoint they give you is negative 8 and 7. Okay. The other endpoint is missing. Okay. The second endpoint is missing. X2, Y2. That's missing. Okay. This is missing. So you're going to use the midpoint formula to figure out what the other endpoint is. Okay. So your midpoint formula, you add the x's together and divide by 2. That gives you your x coordinate for midpoint. Okay, that gives you this. To find the y coordinate for midpoint, you add the y's together, these together, and divide by 2. That gives you this coordinate right here. So this is x1, y1. This is x2, y2. These are your endpoints. This is in the middle. And this is how you get that middle point. Any questions about the logic? Yes, baby?
In the parentheses on the first one, what does the top of the numerator say?
This is x1, y. This is x1, x2. x1 plus x2. You add the x's together. All right, so now in order to figure out what the x2 is, you're going to take the numbers that you have and substitute it in. So here you've got x1 plus x2 divided by 2. And that's going to give you the x coordinate, okay? The x coordinate is -8. See? For midpoint. So your x1 is going to be 1. You see that? So you're going to replace this with 1. So look, only thing that's missing is the x2 coordinate for the endpoint. So in order to solve this, you're going to write this as a fraction and use cross multiplication. So cross multiply. So you have 1 times this numerator, which gives you just this numerator. So rewrite that as 1 plus x2. That's what you get when you multiply 1 times anything, you get that. Bring down the equal. Now you're going to multiply 2 times -8. What's 2 times -8? -16. So now you have to get x2 by itself. So in order to get x2 by itself, you got to move this +1. How do you get rid of the +1? Yes, babe.
You subtract 1.
You subtract 1. Good job. So when you subtract 1 from both sides, this is gone, and your x2 is going to be what? -17. So this is your x2 coordinate, okay, for the endpoint. So now let's find your y2 for the other endpoint. Rewrite that. You have y1 plus y2 divided by 2. Just pick it up, babe. And that's going to equal the y midpoint, the coordinate for y of the midpoint. That's 7. Any questions about where I get 7 from? Okay. So now your y1 is given. Your y1 is also 1. Do you see that? Y1 is also 1. So you're going to replace this with 1. You're going to follow the same steps as before. Write this as a fraction. Ian, I need you to come up to the front, please. You're going to use cross multiplication. So you're going to multiply 1 times this numerator, which is going to give you just this, okay? 1 times anything is going to give you that. So that's going to be 1 plus y2. Bring down the equal. Now we're multiplying. Shh. Come on, pay attention. Pay attention, please, okay? 7 times 2. What's 7 times 2? 14. Okay? So now when we get y2 by itself, what do we have to do? Subtract 1. Good. And what does that give you? That gives you 13. So your y2 is equal to 13. So what's the ordered pair for your endpoint? -17, comma 13. Any questions about what you're supposed to do? Yes, baby.
I'm confused. Why don't we do the same thing we did for Warmup?
Because it's not the same problem. It sounds sarcastic, but I didn't mean for it to. It's not the same problem. In the warm-up problem, it asked us for midpoint. Okay?
Oh.
In the homework problem, they give us midpoint. They want you to find endpoint.
Oh.
Do you see the difference?
Yeah. I don't have the.
I know, because you got to go back and watch the video. Bless your little heart. I need you to do that, though. All right, we moving on. You got to do that, okay? When you're absent, that's your responsibility to catch up. If you need help, then you need to reach out to Ms. Reyes and say, can I come to tutoring, or can I do da 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 da, whatever. But you got to do that, okay? You got to take that extra step so you can get caught up. Any other questions about the homework? Good, okay? All right. I need you to take out your interactive notebook. All right, this is the foldable that you should have, and we're going to cut on the dotted lines. Just put this scrap piece of paper out to the side. You don't need this little slip. Okay, so you're gonna make sure that this side is facing up. Well, actually, no. Sorry. This side is facing up. Okay. Now you're gonna you see where it says example? You're gonna take this and fold it up. Just like this. Poor fella. And then you see these little slits right here, the dotted line, dash line, or whatever. You're gonna take your scissors. I turn it sideways and just cut on the line, all the way down to the fold. Just only cut to the fold, okay? Cut to the fold, and then that's it right there. Okay, make sure you fold this side down. See? I just folded this down this way. All right, let's go ahead and write the notes in this so we can do our practice problems, and I'll turn you loose to do what you need to do. All right, so look, this is how to find the distance between 2 points on a coordinate plane. If you're given a coordinate plane, okay, and you're asked to find the distance between the 2 points, these are the directions of how to do that. Okay, first things first. To find the distance between 2 points on the coordinate plane, you need to graph the points and then connect them. Okay, draw a line from one point to the next point. So you graph points and draw a line to connect them. Draw a line to connect the points. Or ordered pairs, however you want to say that. That's the same thing, okay? So you graph the points, graph the 2 points, and draw a line to connect the points. If the points are laying on a flat line, if you can count how many grid lines it is from one point to the other, if it's laying either horizontal or vertical, then you already know how long it is, okay? Because you can just count the units. If the line is slanted, that means it's cutting through boxes, it's slanted. Then what you do is you're going to use the grid lines to draw a right triangle. Use the grid lines. Yikes. To draw a right triangle. Okay? Yes, babe. Yes, just go. If when the pass come back, just go, please. Use the grid lines to draw a right triangle. You're going to count the number of units, the length of the units for the legs. So you're going to count Stop throwing stuff, don't. Count the length, okay? Count the units for length of legs and use Pythagorean theorem. I'm going to abbreviate Pythagorean theorem, okay? Just put use. We're going to use Pythagorean theorem to solve. Make it short, or try to make it short. Those are the little steps that we're going to use to find the distance between 2 points. Let's do example number 1. Anyone still copying the top part before I move to the examples? Come on, Elijah. All right, here we go. The first example. We're going to follow the steps. The first thing we do is graph the ordered pairs. They're already graphed, okay? M and B are already graphed. We're going to connect. We're going to draw a line to connect the points. So we're going to draw a straight line to connect these points. Try to draw a straight line. This is the distance that they want us to find, okay? From this point to this point. Come on, Sammy. Poor fella. All right, so what we're going to do is we're going to draw a line. So now, look, I can't count how many units it is from this length to this length because it's cutting through boxes. So I'm going to do the second step. I'm going to use the grid lines to draw a right triangle. You see how I'm going to trace this? Trace this line down and trace this line across to draw a right triangle. Any questions about how I drew the right triangle? This is the length I'm trying to find, though, okay? LM or ML. Now what I'm going to do, last thing, is I'm going to count the number of units for the legs, plural legs, sorry, and use Pythagorean theorem to solve. So let's count the units here. This is 1, 2, 3, 4, 5, 6, 7, 8. This is 8 units long from here to here. Any questions about how to count how long this leg is? So now let's count the length of the other leg. Okay. 1, 2, 3, 4, 5, 6 units here. So this is 6 units long. Any questions about how to count the units on those legs? So now we're going to label it. This is going to be my side A. This is B. And the slanted side has to be C. So I have my A and my B. C is the side that's missing. That's the side that I'm trying to find the length for. This is a right triangle. So I can use Pythagorean theorem. A squared plus B squared equals C squared. So let's substitute the numbers in the formula and solve for C. My A is 8, so that's 8 squared, plus my B is 6, so that's going to be 6 squared, and C is missing, so that's C squared. What is 8 squared? 8 times 8.
64.
So we got 64 plus, what's 6 times 6? 36 is equal to C squared. Okay? So we're going to add 34 plus 36. What's 34 plus 36?
100.
It's 100. Bring down the equal, bring down the C squared. Now what do we do to get C by itself? Square root. The opposite of squaring a number is square root. So we square root both sides. What's the square root of 100? So we have 10 here. It's equal to what? C. The square root of C squared is C. Okay, because C times itself gives you the C squared. So the length of LM is C. This is the length of LM. This is line segment. It's equal to 10. It's 10 units long, okay? It's 10 units. Any questions about that? Or ML? Anybody lost? Anybody need me to pause to give you a chance to copy? Are we sure? Angel, you good?
Yeah.
Okay. All right, so let's do example number 2. Okay. So in example number 2, the first thing is to graph the ordered pairs. They're already graphed. And now I'm going to connect the points. Draw a straight line from one point to the other. That's the distance we're trying to find. It's not a vertical line or horizontal line. If it was vertical or horizontal and it actually laid on the grid lines, then you could just count the grid lines and be done. But because it's a slanted line, you're going to have to draw a right triangle to figure out the length. Okay? So let's draw a right triangle. Your right triangle can go upward or it can go downward. It's going to be the same thing. Okay? So this is my right triangle. Any questions about how to use the grid lines to draw a right triangle? Dalton, you good? Okay. So now we're going to count the number of units. How many units is this side right here, this length? 1, 2, 3, 4. Good job. How many units is this length right here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Good job. So we're going to label the sides. We can label this side A, this is side B, and the side that's missing is C, the hypotenuse. Okay? So to find the missing length of a right triangle, you use Pythagorean theorem. That's A squared plus B squared equals C squared. We're going to substitute the sides that we need. This is 4 for A, so this is going to be 4 squared plus 9 for B. This is going to be 9 squared. This is equal. C is missing, so that's C squared. Simplify. This gives you 4 squared. What's 4 squared? 16 plus what? 81 is equal to
97.
Okay. So when you add these together, that gives you 97, someone said. Now what do we do to solve for C? We're going to square root. This is going to be about. So let's find the square root of 97. And what does that give you? About what? About 9.8. Mm-hmm. Yes, babe.
Have you square root the calculator again?
To square root and calculate. Clear. Go to second, the yellow button, and the x squared right here. And then type the number in. You got it?
Yes. Thank you.
You're welcome. All right. Any questions about that? Anyone still copying before we move to example 3? All right. So let's look at example 3. I want you to do example 3 on your own, please. I want you to do example 3 on your own. I'm going to pause for the calls. Okay. So midpoint is page 1. Okay. Don't forget that. Page 2 is going to be what? Anybody remember? The Pythagorean theorem foldable. Page 3 is going to be the Pythagorean theorem worksheet. Page 4 is what? This right here is page 4. Okay? All right. I'm going to go ahead and stop.